Hey, okay, I know the name of the video can be confusing because deep learning obviously works best with a lot of data. And obviously this having a lot of data is always good, right? But what I mean by too much data is, let's say we have 10 million training examples, right? 10 million. Now this is great for our neural network. It's going to learn very good, complex and long data, right? But this is a lot of computations, right? So the issue with this is a ton of computations, right? And no matter whether you do He initialization, Xavier initialization, regularization, normalization, you try a different developer set, maybe you try I don't know, maybe you try different activation functions. And no matter what you try, this is still too much and it's going to be slow, right? So we use something called mini batch gradient descent, right? And I have no idea why I put an A there, but mini batch gradient descent, right? Mini batch gradient descent is gradient descent basically, but it's we're just taking less data, and let me explain that. So let me explain first what batch gradient descent is, right? So batch gradient descent just means you take the entire batch of your training examples. And what I mean by that is capital X, right, your training examples, it goes from X1 to all the way to XM, right, whatever. So, and let's say is equal to, M is equal to 10 million, right? You have 10 million training examples. And let me just put 10M, right? So 10 million examples. And your Y, let me make that capital. Your Y is obviously the same thing, right? It goes from Y1 to uh X, or not X, sorry, YM, right? And Y is also equal to 10 million, obviously. Now this is way too much. But what batch gradient descent means is you just take everything here, take all of this, and you feed it into your neural network. Now, if you want to take a guess what mini batch gradient descent is, we're just going to go take little parts of our training examples. So maybe instead of 10 million, we'll take, just for example, we'll take 5 uh, 10,000 training examples, right? So 50,000. So now x is going to be x to 1 to x. I have no idea why I did that, to x. What's it called, 2x 10,000, right? And this actually still works fine. You're probably wondering, doesn't our data have to be complex? But it still works fine, right? And we're going to take more than 5, right? So capital X is going to be x t, right? Just using t for instance, right? It's going to be an x by t uh, x by t matrix. And what I mean by that is t is going to represent the mini batch, right, that we're using. So t is going to be the mini batch we're using. Sorry for the terrible handwriting, right? So t1 is the first 10,000, right? T2 is your second 10,000 training examples, right? Remember, we have 5 of these, and so on until we reach T5. So really, this is from a T1 to a T5, right? Whatever. And it should be superscript. So actually, let me fix that so it's not confusing. What the fuck? Okay. Let's not do that, I guess. Why is it like that? 4 maybe. There you go. Okay. So okay, that is terrible. Let me try a smaller size, right? T1, somehow still too small. By by X superscript T, right? And yeah, just T. So now your weight parameter is obviously just going to be, and this isn't super important right now, I'm just explaining what mini batch is, right? But weight is going to be, it's going to be a W1 layer, right? Your first layer, but it's going to be by T, right? So literally all we're doing is instead of taking all 10 million training examples and feeding into our neural network, we're going to have our neural network, but we're only going to feed 50,000 in here, right? And pretend this is 50,000. So this is 50,000 training examples, right? And that gets fed into this. And that's all mini batch gradient descent is. Instead of taking all 10 million, you're going to take many batches.